The year was 1925. Americans danced the Charleston and devoured the Great Gatsby, while across the Pacific, Japan was emerging from an industrial transformation. In Illinois, a merger birthed Caterpillar Tractor Company, and in Japan, Komatsu began crafting its first machines after splitting from a mining company. Neither knew they were creating a rivalry that would span a century. In recent decades, Caterpillar and Komatsu have together held a commanding position in the global construction equipment market, powering infrastructure projects around the world. From World War II, where Caterpillar equipped Allied forces while Komatsu supported Japan, to today's race for autonomous mining trucks, this isn't just business competition, it's an engineering battle that built our modern world. The stakes now, the future of infrastructure, and perhaps the planet itself. November 24, 1904, Stockton, California. A steam tractor belches smoke as it drags a plow through dry soil. This is where Caterpillar's story begins, not with bulldozers, but with farmers trying to replace horses. Benjamin Holt's company had been experimenting with solutions to a simple problem. Wheels sank in soft soil. His breakthrough came when he replaced wheels with tracks, creating the first practical track-type tractor in 1904. They called it the Caterpillar because it moved like the insect. When World War I broke out, generals faced their own traction problem, moving heavy artillery through muddy battlefields. They noticed something unexpected. Holt's farm tractors could haul guns where horses couldn't. During the First World War, British forces placed substantial orders for Holt tractors, recognizing their superior performance in difficult terrains. These machines became the backbone of Allied logistics, moving supplies and weapons across the Western Front's ruined landscape. Meanwhile, in Japan, Komatsu's parent company was still producing mining tools, unaware of the industrial transformation ahead. The 1925 merger between Holt Manufacturing and CL Best Tractor Company created Caterpillar Tractor Co. Just as America's construction boom began. Their first combined product, the Caterpillar 60, could pull road graders and carry bulldozer blades, making it the first true multi-purpose construction machine. By 1931, Caterpillar had sold over 100,000 machines worldwide. But across the Pacific, a different story was unfolding. Komatsu was taking its first steps toward heavy equipment production. Komatsu split from its mining parent company in 1921 with a clear goal: build Japan's first domestically produced bulldozer. For a country recovering from the 1923 Great Kanto earthquake, this was a matter of national pride. Their first attempt in 1931, the Komatsu G25, was a reverse-engineered Caterpillar copy. But Japan's steel quality couldn't match American manufacturing yet, leaving Komatsu's early machines prone to breakdowns. When World War II began, both companies became essential to their nation's war efforts on opposite sides. Caterpillar's robust machinery fleet, numbering in the tens of thousands, proved indispensable to Allied forces by rapidly constructing airfields and essential infrastructure. These same machines later helped reconstruct Europe. Komatsu shifted to producing tanks and artillery components, adapting their tractor suspension system for Japan's Type 95 tank. The war reshaped both companies. Caterpillar's factories perfected mass production, while Komatsu's facilities were devastated by Allied bombing. By 1945, Caterpillar dominated America's construction equipment market. Komatsu, rebuilding from scratch, faced a shattered economy and strict production bans under MacArthur's occupation government. Yet Komatsu had one advantage: decades of studying Caterpillar's designs. When the Korean War spurred demand for construction equipment, Komatsu restarted production with improved bulldozers, refining designs using scavenged steel and innovative engineering. Wartime pressures had forged two industrial giants, setting the stage for a fierce post-war rivalry. Stand in the middle of an Oklahoma dust storm in 1934. The air is thick with dirt, visibility near zero. You hear it, the deep growl of a Caterpillar 60 pushing through the swirling dust. This machine isn't just moving earth, it's fighting to keep farms from turning into desert during the Dust Bowl. Caterpillar's timing was critical. As the Great Depression hit, they introduced the diesel-powered D2 tractor in 1938. While other companies went bankrupt, Caterpillar found steady work through Roosevelt's New Deal projects. The Hoover Dam became Caterpillar's proving ground. At this project, engineers relied on a dedicated fleet of Caterpillar machines to move millions of cubic yards of material, underscoring the machine's critical role in such monumental efforts. The project was so massive that Caterpillar set up a dedicated repair shop on site. Their machines worked around the clock in temperatures reaching 120 degrees Fahrenheit. One operator later recalled, "Without those machines, we'd still be digging." When World War II came, the same models that built American infrastructure were repurposed to construct military bases and airfields. In Alaska, Caterpillar graders operated in -50 degree Fahrenheit conditions to build the Alaska Highway, a vital supply route to the Pacific Theater. Meanwhile, across the Pacific, Komatsu faced a different reality. The war had destroyed much of their industrial capacity. Under American occupation, heavy equipment production was initially banned. When restrictions lifted in 1947, Komatsu had to start from scratch. Their early post-war bulldozers, inspired by Caterpillar's designs, couldn't match American manufacturing because of Japan's steel quality, and Komatsu's machines broke down frequently, earning a reputation for poor reliability. The cultural contrast between the two companies was stark. Caterpillar symbolized American industrial might, its yellow machines icons of post-war prosperity. Komatsu, on the other hand, embodied Japan's determination to rebuild. Their factories operated under the slogan Maru-si, meaning encircle Caterpillar. Early attempts fell short. A historical review of mid-20th century military equipment noted that early post-war era Japanese-manufactured bulldozers required major repairs after significantly fewer hours of use compared to their American counterparts. This disparity highlighted the technological and industrial challenges faced by Japan's machinery sector during its post-war recovery period, while US-made equipment of the same era was generally regarded as more durable. Everything changed in 1953 when Komatsu landed a contract to supply equipment for Japan's reconstruction. The government demanded better quality, forcing Komatsu to innovate. They studied American manufacturing techniques but adapted them to Japan's limited resources. Instead of relying on high-quality steel, they redesigned components to distribute stress more efficiently. By 1955, Komatsu's D50 bulldozer showed marked improvement. It cost 30% less than Caterpillar's designs, a crucial advantage for cash-strapped Japanese contractors. Caterpillar responded by expanding globally, opening factories in Brazil and the UK. Their machines became standard for the US Army Corps of Engineers. As the interstate highway system took shape in June 1956, Caterpillar emerged as a key supplier of earth-moving equipment that helped build the nation's roadway network. The turning point came in the 1960s. Komatsu introduced the D80, featuring a revolutionary hydraulic system that outperformed Caterpillar's cable-controlled blades. For the first time, Komatsu's domestic market share surpassed Caterpillar's imports. This era set the pattern for their rivalry. Caterpillar leading through scale and reliability, Komatsu through adaptation and cost. As Japan's economy boomed in the 1960s, Komatsu set its sights on competing globally against Caterpillar's century of experience. Tokyo, 1963. A team of Komatsu engineers took apart a Caterpillar D7 bulldozer bolt by bolt. Their findings shocked the company leadership. While their own machines needed major repairs after just 1,000 operating hours, CAT's identical components lasted 10,000 hours. Komatsu President Yoshinari Kawai gathered his executives and delivered an ultimatum. Beat Caterpillar in quality within 3 years, or we'll quit the business entirely. The room fell silent. For a company already struggling to compete, this was a do-or-die moment. This ultimatum sparked Komatsu's quality revolution. Without Caterpillar's century of manufacturing experience or access to superior American steel, they turned to the Total Quality Control (TQC) system inspired by Toyota. Every worker, from the factory floor to the design office, joined quality circles to identify and eliminate defects. The results were dramatic. Within 5 years, Komatsu reduced warranty claims by 60%. The real breakthrough came in 1967 with the D85 bulldozer. For the first time, a Komatsu machine matched Caterpillar's durability benchmarks. Its new frame design distributed stress more evenly, compensating for Japan's weaker steel. The undercarriage used special alloy pins that lasted twice as long as previous models. Most importantly, it cost 30% less than equivalent Caterpillar models. Dealers noticed. For the first time, construction companies buying Komatsu were no longer settling for a cheaper option. They were getting equal quality at a lower cost. Meanwhile, Caterpillar faced a crisis at home. In 1967, their Illinois factories became battlegrounds during the union strike over wages and conditions. Production lines ground to a halt just as global demand for construction equipment skyrocketed. The strike exposed a stark contrast in philosophies. Komatsu embraced lean methods, while Caterpillar doubled down on vertical integration. In 1979, they built one of the world's largest iron foundries in Mapleton, Illinois, to control every step of production. This guaranteed quality but increased costs. Their new D9 bulldozer epitomized this approach, with every critical component sourced from Caterpillar-owned factories. The divergence became clear in the 1970s Middle East. Oil revenues fueled massive infrastructure projects, and contractors needed equipment fast. Caterpillar's order backlog stretched to 18 months due to their complex supply chain. Komatsu, operating with just-in-time inventory, delivered similar machines in 6 months. In 1974, Kuwait's Ministry of Public Works placed an order for 500 Komatsu dozers, their biggest international deal yet. Komatsu's quality turnaround had unexpected consequences. For decades, Caterpillar executives dismissed them as a copycat manufacturer, but by 1975, Komatsu developed technologies Caterpillar lacked. Demonstrating its commitment to innovation, Komatsu became one of the first in the industry to integrate digital control systems for more precise blade adjustments, setting new benchmarks in operational efficiency. The QC Circle initiative kept delivering innovations. Workers suggested 40 improvements to the D85's hydraulic system alone. Caterpillar responded by tightening dealer networks. They pressured contractors through financing deals, offering better lease terms for customers who bought exclusively Caterpillar equipment. Their superior parts distribution network became a key selling point. A Cat mechanic could get any replacement part within 48 hours almost anywhere in the world. Komatsu countered by undercutting dealer profit margins, allowing them to offer better prices. Independent tests showed Komatsu's machines nearing Caterpillar's durability benchmarks by 1980. In Australia's Pilbara mines, Komatsu outperformed Cat in extreme heat thanks to redesigned cooling systems. This became Komatsu's new marketing angle. They weren't just competing anymore, they were excelling in the toughest conditions. Nevada's Bingham Canyon Mine, 1996. A Komatsu 930E haul truck lumbers up a 10% grade carrying 290 tons of copper ore. At first glance, it seemed like just another mining vehicle, but hidden beneath its steel frame was a quiet revolution. Advanced sensors and microprocessors, borrowed from Japan's consumer electrics boom, were embedded within. These systems would soon redefine heavy equipment, while competitors like Caterpillar focused on building bigger, more mechanical trucks. Komatsu pioneered early GPS integration in bulldozers, introducing systems that automated blade adjustments with unprecedented precision. At first, it looked like any other bulldozer, but operators quickly noticed something different: a small screen displaying real-time blade position data. It was among the first bulldozers to integrate GPS technology, setting a new standard for precision in earth moving. Initially dismissed as a gimmick, the technology proved its worth when contractors reported a 40% reduction in earth-moving costs. By combining satellite positioning with onboard gyroscopes, the system automatically adjusted the blade to within 2 centimeters of design specifications, transforming precision grading into a science. Caterpillar, confident in their mechanical simplicity, initially dismissed these innovations. Their customers valued mechanical simplicity. A Cat 797 mining truck could operate for years with basic maintenance. But by 2000, mine operators began demanding Komatsu's precision systems. Caterpillar responded by forming a joint venture with Trimble, Caterpillar Trimble Control Technologies, CTCT, on April 1, 2002, to develop and manufacture advanced electronic guidance and control products for earth-moving machines, gaining access to laser grading technology. This move kept them competitive, but Komatsu was already pushing further. Komatsu adapted advanced navigation systems for mining trucks. The market split along technological lines. Caterpillar dominated North American surface mines with mechanical giants like the 797F, a 400-ton truck powered by a 4,000-horsepower diesel engine. These machines thrived in coal mines where brute force was king. Meanwhile, Komatsu excelled in Asia's quarries with computer-controlled excavators like the PC-8000. Its hybrid hydraulic system cut fuel consumption by 25%, a critical advantage in regions with high diesel costs. Operator preferences revealed a cultural divide. American miners favored Caterpillar's analog controls, levers and pedals that provided direct mechanical feedback. In contrast, Komatsu's joystick controls and data-rich cabs catered to precision-focused operators. By 2005, a Komatsu excavator operator could monitor fuel efficiency and load metrics in real time, optimizing every liter of diesel. The automation race accelerated in 2008 when Komatsu deployed the first autonomous haulage system at Chile's Gabi copper mine without drivers. Their front-runner technology used GPS and obstacle detection sensors to guide 930E trucks without drivers, operating 22 hours daily compared to human drivers 12. Caterpillar countered with their command system in 2013, but it required costly infrastructure. Komatsu's solution, leveraging existing 4G networks, proved more adaptable. By 2015, the gap was clear. Komatsu trucks moved 18% more tons per hour at Australia's Jimblebar mine, though Caterpillar's mechanical drivetrain still excelled in extreme cold. Walk into a Texas construction site trailer and you'll see two kinds of coffee mugs. Ones with Caterpillar logos and ones that say Komatsu with the K crossed out. This goes beyond brand preference. It's a tribal loyalty that defines the job site. Caterpillar operators often describe their machines with a reverence that borders on the spiritual. One veteran operator explained, "When I'm running a Cat, I can feel the machine's heartbeat through my boots. It's like the engine and I are working in sync, every vibration telling me what it needs." Komatsu fans, on the other hand, lean on data to express their loyalty. They'll eagerly show you spreadsheets proving their Komatsu's hybrid excavators demonstrating significantly lower fuel consumption than competitors. They highlight the precision of their machines, like digital displays that track every ounce of hydraulic fluid and predict maintenance weeks in advance. A quarry manager in Arizona put it this way, "My Komatsus don't just run, they communicate. They tell me when something's off before it becomes a problem. With Cats, you find out when they stop working." Even dealers play into the rivalry. Many Caterpillar locations refuse to service Komatsu machines, while Komatsu counters with aggressive trade-in programs, offering $15,000 discounts to contractors who switch from Cat. On job sites, the rivalry is palpable. When a new Komatsu excavator shows up, Cat operators might accidentally scrape it with their buckets. Komatsu crews retaliate by leaving printouts of fuel efficiency reports in porta potties. A foreman in Colorado shared, "We had to ban brand talk at safety meetings after two guys nearly came to blows over hydraulic response times." The psychology behind these preferences reflects deeper values. Caterpillar represents American mechanical tradition, overbuilt components, simple controls, and a belief that torque solves everything. Their machines are designed to endure, with a philosophy unchanged since the 1960s. Komatsu, by contrast, embodies Japanese precision, with every system optimized and monitored. Their cabs, filled with touchscreens and data displays, feel more like airplane cockpits compared to Cat's utilitarian controls. Dealer networks play their part too. Caterpillar's expansive network has long been synonymous with reliability and parts availability, while Komatsu's dealers emphasize advanced technology support and operator training. This loyalty pays off. Cat owners rarely switch, even when Komatsu offers better specs. Meanwhile, Komatsu's hybrid models are reshaping the used market, proving that innovation can challenge tradition. July 8, 2011. Caterpillar CEO Jim Umpleby stood before analysts explaining why he'd just spent $8.6 billion on Bucyrus International. The deal gave Caterpillar something they lacked for decades: dominance in underground mining equipment. Bucyrus made the giant shovels that load ultra-class haul trucks, completing Caterpillar's surface mining lineup. However, the acquisition came with risks. For the first time, Caterpillar would rely on outside suppliers for critical components, breaking their tradition of vertical integration. This shift made Wall Street uneasy, and Caterpillar's stock dropped significantly after the announcement. The strategic rationale became clearer when examining mine operations. Before the deal, a mining company might use Cat haul trucks, but Komatsu shovels. With Bucyrus, Caterpillar could now offer a full suite of equipment, from the mine shaft to the port. Their catalog expanded to include Bucyrus's massive rope shovels with 42 cubic meter buckets, capable of loading a 400-ton truck in just 4 passes. But integrating Bucyrus proved challenging. Caterpillar had to keep Bucyrus's Milwaukee factories running while retooling their own plants, a process that stretched over 5 years. During this transition, some customers stuck with Komatsu for consistency. Komatsu responded quickly, acquiring Joy Global for $3.7 billion in May 2017, their largest purchase ever. Joy made competing underground equipment, but also overlapped with Komatsu's surface mining products. This acquisition led to overlapping product lines, creating confusion among customers about competing models. This lack of clarity hurt investor confidence, and Komatsu's stock dropped significantly as questions arose about the acquisition's logic. The acquisitions highlighted contrasting strategies. Caterpillar aimed to control every piece of equipment at a mine site, offering mine systems packages that bundled trucks, shovels, and drills with integrated monitoring. Komatsu, on the other hand, focused on technology integration. They partnered with Rio Tinto to develop autonomous haulage systems, prioritizing a data ecosystem over equipment variety. A Rio Tinto manager noted, "Komatsu understood we wanted a data ecosystem." Financial results reflected these trade-offs. Caterpillar's mining revenue grew 38% post-acquisition, but integration costs hurt margins, including an $800 million write-off for redundant inventory. Komatsu saw quicker returns from Joy's aftermarket parts business, but struggled to merge sales teams. A former Joy dealer in Pennsylvania remarked, "Komatsu treated us like we sold inferior equipment. They didn't understand Joy's customer relationships." Both companies faced challenges as the mining industry grappled with uncertainty. Electric vehicle adoption raised questions about long-term demand for coal and copper. Caterpillar positioned Bucyrus's shovels for lithium mining, while Komatsu emphasized Joy's continuous miners for potash. Yet when commodity prices dipped in 2019, Caterpillar idled Bucyrus plants and Komatsu cut Joy's workforce by 15%. The Gotthard Base Tunnel construction site in Switzerland looks different in 2023. Workers noticed the absence of diesel fumes first. Then they realized the Komatsu excavator makes no engine noise, just the whir of electric motors and the clank of steel. This machine, designed to run for extended periods on a single charge, symbolizes Komatsu's commitment to electrification, mirroring the broader industry push toward cleaner technology. Nearby, a Caterpillar excavator rumbles on, burning diesel like its predecessors have for a century. The contrast is striking. One machine hums like a stealth fighter, quietly redefining the future, while the other roars with the power of tradition. Komatsu has bet big on batteries, offering electric models across multiple weight classes. Their strategy mirrors Japan's automotive industry, commit fully to electrification. Their strategy emphasizes swappable battery packs for continuous use. However, cold weather reliability remains a challenge. During extreme winter conditions, some electric machines struggled with battery performance, prompting concerns about durability in harsh environments. Caterpillar's alternative? Hydrogen. They're testing internal combustion engines that burn hydrogen instead of diesel. These engines work in any temperature but require new fueling infrastructure. Geography shapes adoption. In Europe, cities like Oslo and Amsterdam mandate zero-emission construction sites by 2025, making Komatsu's electric equipment the dominant choice, outselling Caterpillar by significant margins. Conversely, in industries like oil and gas, where uptime is critical, diesel remains dominant. A Houston contractor summed it up, "I need machines that run 24/7. Until electric can match diesel, I'm not switching." Caterpillar leans into this mindset, designing hydrogen prototypes that look and feel like their diesel counterparts, easing the transition for operators. Supply chains reveal another divide. Battery production relies on materials like lithium and cobalt, which face geopolitical and ethical sourcing challenges. Hydrogen combustion, by contrast, leverages existing manufacturing infrastructure with modifications, and some Caterpillar dealers have begun repurposing gas handling equipment for hydrogen distribution, demonstrating logistical flexibility. Performance data highlights trade-offs. Komatsu's electric excavator delivers 30% more torque at low RPMs, ideal for precision work, but lacks the continuous power of Caterpillar's hydrogen prototype in heavy digging. In mining operations, hydrogen machines reportedly moved material more efficiently per day, though electric models had lower operating costs due to cheaper energy inputs. Regulations are accelerating change. California's Advanced Clean Fleets rule requires zero-emission equipment purchases starting in 2024. Komatsu to expand US battery production, while Caterpillar has lobbied to include hydrogen combustion in zero-emission classifications in certain regions, citing its compatibility with existing workflows. Both companies innovate beyond machinery. Komatsu's smart charging systems sync with renewable energy, while Caterpillar's mobile hydrogen refuelers serve remote sites. The race to decarbonize construction pits quiet battery-powered precision against the roaring adaptability of hydrogen. Pilbara, Australia. A 400-ton Komatsu autonomous haul truck rumbles towards a rockfall it detected 30 seconds before human operators noticed the danger. Without hesitation, it recalculates its path, broadcasts a warning to nearby vehicles, and continues hauling iron ore, all without a driver in the cab. This is Komatsu's front-runner system in action, one of 1,200 autonomous trucks now transforming mines worldwide. The technology tackles mining's biggest cost: labor. But the way Komatsu and Caterpillar approach automation reveals starkly different philosophies. Caterpillar's command system charts a more controlled path, while Komatsu relies on existing 4G networks. Cat demands mines install proprietary radar and GPS infrastructure. Their autonomous 794 trucks follow magnetic strips embedded in haul roads like a train on invisible tracks. The results are impressive. At Fortescue's Solomon mine, Cat's fleet moved 30% more material than human drivers, but the price tag is different. Caterpillar's autonomous systems required significant upfront investment, while Komatsu offered more cost-effective solutions leveraging existing networks. Resistance from workers adds another layer of complexity. When Caterpillar introduced autonomous tech at an Arizona copper mile, union operators fought back. They sabotaged the system by placing rocks on haul roads to confuse sensors and triggering emergency stops. Komatsu faced less hostility in Australia, where unions negotiated deals allowing human operators to monitor multiple trucks from control rooms. A Rio Tinto supervisor summed it all up. "Our guys realized one operator overseeing 5 trucks beats driving one in 120-degree heat." The data strategies of these rivals diverge sharply. Komatsu's trucks generate 500,000 data points daily, tracking everything from brake pad wear to optimal speeds for road grades. This feeds into their smart construction platform, predicting maintenance weeks in advance. Caterpillar, prioritizing security, processes most data on board and shares only critical alerts. A Freeport McMoran engineer explained, "Komatsu gives us spreadsheets of efficiency metrics. Cat just tells us when something's broken." Regional preferences highlight the divide. Caterpillar dominates North America, where cybersecurity and union concerns take precedence. Komatsu leads in Australia, where remote locations favor cellular networks. At Chile's Escondida mine, both systems coexist. Komatsu's trucks excel on steep grades, while Cat shine in dust storms that disrupt GPS. The human factor remains volatile. Veteran operators often distrust automation. Caterpillar eases the transition with trucks that can switch to manual mode. Komatsu, fully committed to automation, removed cabs entirely, sparking backlash at a South African mine. Workers refused to maintain robot trucks, forcing the mine to create new technician roles. Adaptability may decide the future. Caterpillar's acquisition of MineStar enables mixed fleets, while Komatsu's partnership with NVIDIA pushes AI to learn from human operators. Both aim to merge human expertise with machine precision. Here's the twist in this century-long rivalry. Caterpillar and Komatsu actually need each other. Without Komatsu pushing innovation, Caterpillar might have stuck with mechanical controls forever. Without Caterpillar setting the quality standard, Komatsu wouldn't have transformed from a copycat into a tech leader. The real winners, every construction crew, mine operator, and infrastructure project that benefits from their battle. Better machines, smarter tech, and tougher competition. So, where do you stand? Are you Team Cat, loyal to that diesel roar and raw power? Or Team Komatsu, championing precision and electric efficiency? Let the debate begin. Drop your pick in the comments, like this video, and hit subscribe. Which battle do you want us to cover next? Let us know.